Hello, welcome to today's class. My name is Mr. Modulus. In today's class, I will lead on some mathematics. So our favorite topic today is variation. So let's get started. Okay, so what is variation? Of course, variation in mathematics is a term used to refer to two or more quantities in such a way that a change of one quantity affects the change of another. Let me give you an instance. So supposing we have a circle here. So this is a circle. And this is the center of the circle, right? Of course, any straight line that passes through the center of the circle is the diameter of the circle. So this is the diameter of the circle. And also any straight line from the center of the circle to any point of the circumference, this is the circumference of the circle, is the radius. So from here to here is the radius of the circle. So here, I will call here radius of the circle. Also, any straight line from the center of the circle to any point of the circumference is also the radius, like I said before. So here is also the radius, all right? So from here to here is the radius, and all that. Now this is, let me say, this is a minor circle. Let me draw a larger circle. Okay? So let me assume that here is my circumference. Don't mind, it's not perfectly in a circular manner, but let's manage it. So this is my diameter. All right, so I will donate this diameter now with capital D, and from here to here, remember the diameter is a straight line that passes through the center of the circle, right? So y radius is any line from the center of the circle to any point of the circumference. So here is the diameter, and I will call here my radius, all right? And here is also my radius. From here to here, radius. So I want to use capital R to denote the radius of the bigger circle, and the capital D to represent the diameter of the bigger circle. Now I want you to consider these two diagrams and notice something. Notice that as the diameter gets bigger, the radius also gets bigger, because the length from here to here is bigger than the length from here to here. That is, this radius is bigger than this radius. So notice in these two diagrams that the radius R of the bigger circle, the radius capital R of the bigger circle is greater than the radius R of the smaller circle. And diameter D, capital D of the bigger circle is greater than diameter small d of the smaller circle. So what do you observe? You observe in this case that as the diameter small d increases, as the diameter of this circle increases from small d to bigger D, all right, then the radius of the small circle increases from small r to bigger R. So notice that a change in diameter brings about a change in radius. So if a circle has a smaller diameter, of course it will have a smaller radius. Then if the diameter of the circle increases to bigger diameter, of course the radius of the circle will also increase to bigger radius. So realize, and from here notice that there is a relationship between the radius of a circle and the diameter of a circle. So, and this relationship explain or deduce that a change in diameter will bring about change in radius. And this change, this relationship, the word that describes this relationship between the change in diameter and radius is what we call in mathematics variation. So variation in mathematics is defined as a change, or is defined as a relationship between quantities whereby a change in one quantity leads to the change of the other. Or it is defined as a situation or a change of one quantity due to change of another quantity. All right? So now we'll be talking about the types of variation. So types. types of variation. Basically, variation can either be direct or inverse. All right, every other form of variation is an extension of these two. Okay, so the number one variation we have is direct variation, direct variation, and the second one is indirect, but which we alternatively call inverse variation. Then the third is joint variation. And the last but not the least is partial variation. Of course, basically, variation is either direct or inverse. So joint and partial is an extension of these two variations. So we are going to elaborate each and every one of them. Remember what I told you initially, that variation is defined as a relationship between two quantities whereby a change in one quantity leads to a change in the other. That is, a change of one quantity affects the change of other quantities. So there must be a relationship between quantities, and there will also be a change in one quantity which will affect the change of other quantities. And these are the four types of variation we have under elementary mathematics. All right. So let's start with the first one, which is direct variation. Now, what is direct variation? Now, this relationship, let me go back to this circle. Now, if you look at this, you will realize that the diameter here is the sum of the two radii. Remember, the plural form of radius is radii. It's the sum of the two radii, because from here to here is one radius, from here to here is another one radius. Then from here to here plus from here to here is the diameter. So you realize that from here to here plus from here to here, which is diameter, is the two radii. All right. So from this circle here, I can say that diameter is radii plus radius, which is equals to r plus r is 2r, which is 2 radii. So you realize that there is a relationship between the diameter and the radius. And you will notice that as the diameter increases, the radius increases. Like at this case, as d gets bigger, so from here I can also say capital D is equals to capital R plus capital R. Therefore, the bigger diameter is equals to the bigger radius plus the bigger radius. So therefore, we can say that capital D is 2 capital R, which is the bigger diameter is equals to 2 radii. The radii of the bigger radii, right? So when you see that as D increases to capital D, R increases to capital R. So that is it. And this type of variation is called direct variation, because direct variation is talking about whereby a quantity varies on a similar manner with another quantity. All right. So now I'm going to now define direct variation. If A varies directly as B, then as A increases, comma, B increases as well, and as A decreases, and as A decreases, comma, B decreases. All right. So this is for I. The first definition. Another definition, which is a direct definition, is that A varies. I can say definition I. Let A and B be quantities. A varies directly, A varies directly as B if A changes on a similar manner as B. So if A changes on a similar manner as B, that means if A is increasing, B is increasing. If A is decreasing, B is decreasing. So if two quantities varies, so let us introduce our variation notation. So this is variation notation. So our variation notation is like this, all right? Okay. It looks like alpha, right, in Greek. Okay, this is our variation notation. So A varies as B is written like this. A varies directly as B is written. A varies directly as B is denoted as A varies as B. So this is A varies directly as B. So this is how we denote direct variation, all right? So I'm still coming to this because this is a direct variation. I am going to use it to explain this. So A varies directly as B is written like this, all right? Now, that two quantity varies does not mean that they are equal. We only say that two quantity varies when a change in one leads to a change in the other. Now, you know, in mathematics, we can't solve any problem if we do not set an equation connecting those problems, all right? So the essence of the equation is to help us to solve the problem. So in this case, for we to begin to establish a system that will enable us to solve a problem of variation, we need to establish an equation that connects the quantities. And we have already given the symbolical aspect of the variation of two quantities, which is A varies as B written like this. So from here, we need to create an equation, all right? We need to set up an equation that will enable us to solve the problem, okay? Now, how do we do that? We already know that as a quantity varies as another doesn't mean that they are equal. So how do we create an equality between the quantities? Now, the question will be answered easily if we understand that for a quantity to be equal to another quantity, if they are not equal actually, then that means we can introduce some constant whereby if you multiply it to one, it will give you the other. For instance, we already know here that diameter of a circle varies directly as the radius. And from this diagram, we observe that the diameter is equal to 2 radii. Now, if you compare these two things, you realize that this is R, of course, and this is D, of course. Now, the remaining thing between D and R here is equal with constant 2. And the remaining thing between D and R here is variation sign. So what does this thing mean? It simply means that the variation sign is being replaced with equal and 2. Now, I want you to understand the wisdom here. The wisdom here is that for equality to exist between D and R, because already there is no guarantee that D and R are equal. So before equality can exist between D and R, there is a need for introduction of a constant, whereby if that constant multiply one quantity, it will be equal to the other quantity. So the essence of this equality, the cause of this equality is the introduction of this constant 2. So you see that when quantities varies, they are not really equal. There is no guarantee they are equal. So to be able to create an equality between the quantity, we need to introduce a constant. So the job or the purpose of that constant is to bring the equality. So the existence of the equal sign in the equation of variations of quantity is as a result of the introduction of a constant. So when you say that quantity varies and you want to establish an equation, you need a constant. So if you can't introduce a constant, then there will not be an initiation of what? Equality sign. So I wish to believe that you have understood what we mean by this. All right? So which means that once you have this kind of situation, to bring equality there, we need to introduce a constant. So such that when the constant multiplies one quantity, it will be equals to the other quantity. So here, when 2 multiply radius, it becomes equals to diameter. Originally, diameter and radius are not equal. All right? They are not equal. There is no guarantee they are equal. But what guarantees their equality is what? The constant. All right? Which is whereby the constant multiply the radius and give it diameter. So thank you. Let's go. So from here, if A varies directly as B, then A is equals to KB. So in this case, our K is constant, where K is constant. So our job is to find the constant, because the quality of this A and B depends on the constant. All right? So if the constant here is 2, that means A and B are likely to be diameter and radius, as we have depicted already. All right? So when you have something like this and it happens that 2 is the constant between 2 quantities which are equal, 2 is the constant, then it's likely that the constant here having a coefficient of 2, I mean the variable here or the quantity here having a coefficient of 2 is radius, and this one is diameter. I'm just using it as a point of explanation. All right? Okay. So our job is to find this constant. So that is the formula for direct variation, where K is constant and these two are the variables. You know why they are the variable? Because they are the quantity that changes. All right? So the change of A leads to change of B, and this equation shows that A is in direct variation with B, or A varies directly as B, or A varies as B. Remember, direct variation, if A varies directly as B, something as say A varies as B. All right, so let's solve a problem. So example. Okay, so the question says A varies directly as B and A is 6 when B is 3. Find I, the relationship between A and B. I, A when B is 4. I, B when A is 12. Alright? So let's get started. So obviously from this question, we are told that A varies directly as B. So if A varies directly as B, that means we can use this equation. All right? So I managed to use the same A and B here, but we can use any letter can be used. All right? So in direct variation always have this formula, this equation. So in this kind of situation, we can say that A varies directly as B. All right? So A varies directly as B Okay, let me write the question says when A is 6, B is 3. Now, I will tell you the reason for everything here. The value of A and B was given at a particular time or point because you need this value to find a constant because of the constant. All right. So if the constant can be found after you establish the equation, then you can find anyone given anyone. You know, if you don't establish the relationship between the two quantities, you can't find any quantity given anyone. All right. And the only way to establish the relationship or the equation connecting the two quantities is to first of all demonstrate their equations, find the constant involved. Then after finding the constant involved, then you can find a particular quantity given the other. All right. So I have told you that you need to introduce the constant. It is the constant that will bring the what? Equality, bring about the equality. And when you find the constant, you can be able to solve the problem. All right. So let's go. So since from the question A varies directly as B, right? And this implies how to write direct variation, and this implies that A is equals to KB, where, so for the time being, we are using K as our constant. It's not only K, we can use C and any other letter as a constant, where K is constant. Alright? So, now, the question said that when A is 6, B is 3. So if we put A at 6, if we substitute A as 6 here, we substitute B as what? 3. So therefore, we can have that 6, which is A, will be equals to K into B is what? 3. At this point, you can go and watch my videos on equations, solving equations. At this point, we divide both sides by 3 because 3 is multiplying K. So we need to eliminate 3 so we can find the value of K. And how to eliminate it is to divide by 3 because 3 is multiplying. So opposite of multiplication is division. So if we divide both sides by 3, we have that 6 over 3 is equals to K into 3 over 3. So 3 cancel 3. So 6 over 3 is what? 2. So K is 2. So here, therefore, our K is equals to 2. Okay? So we have gotten our constant. So we can replace K now with 2. So we now have that A is equals to 2B. Of course, this thing look like the variation of diameter and radius. Remember, in diameter and radius, we have that diameter is equals to 2 radii, right? 2 radii, where B is representing radii and A is representing what? Diameter. I intentionally said the question like this so I can invite diameter and radius. Okay. Now, we have established the first part, relationship between A and B. So this is the relationship between A and B, or the equation connecting A and B. Okay, the second one, the II, we are meant to find A when B is 4. So when B is 4, when B equals to 4, therefore, look at the equation. You now use the equation to now find one quantity given the other. So therefore, our A will now be 2 times, B is 4 already, right? 2 times 4 is what? 8. So when B is 4, our A is 8. From the equation, A is twice B, all right? So whatever you get as your B, if you multiply by 2 or if you double it, you get A, all right? So that is it. Now, I, we should find B when A is 12. So when A equals 12, so let's go here and complete it. When A equals 12, so in our formula, we meant to have that A is equals to 2B. So we'll put 12 here to have that 12 will be equals to 2B. So at this point, 2 is multiplying B. So we'll make B the subject. And how to make the subject? By removing 2. How do you remove 2? We divide by 2. So this is an equation. We divide both sides by 2. So we now have that 12 divided by 2 is equals to 2B over 2. So 2 we cancel 2. 12 over 2 is what? 6. So our B is equals to 6. So therefore, B is equals to 6. Alright, that's by the way. So we take one more example, then we go to inverse variation. X varies as the square, X varies as the square of Y. and x is 16 when y is 4. Find I, the equation connecting x and y. X when y is 3, and y when x is 36. Solution. Okay, they say the question say x varies as the square of y. Now, I've told you before, maybe you have forgotten, when a quantity varying directly as another quantity is something as saying a quantity varies as another quantity. So when you hear A varies as B, it means A varies directly as B. Here, T varies as R, it simply means T varies directly as R. So varies and varies directly are the same. If it is inverse, remember a variation in this context can either be direct variation or inverse. So if you did not see the word inverse there, it simply means it is what? Direct variation. Okay, thank you. So this is direct what? Variation. Variation, like I said, can either be direct or inverse. Any other variation which is joint and partial is an extension of what? Direct variation and inverse variation. Thank you. So the question says that x varies. Okay, let's write the parameter first. So when x is 16, when x is 16, y is 4. Now the question says that y varies as the square of y. What is square of y? Y square. This is square of y, alright? This is y square, which is square of y. So the question says x varies as the square of y, which means x varies directly as the square of y. So from the question, x varies as the square of y. So that is how to write the variation. That x varies as the square of y. So this is the variation notation. So this means this is equals to x. Okay, this means that x is equals to k. So they are not equal. So to bring equality between them, we introduce a constant, all right? It is the constant that will bring the equality between the two quantities. So x varies as the ky what? Square, where k is constant. So our k is constant. Okay? So here, the question says, from here, this is our equation. This is our equation. So from here now we can solve. We can find the value of k. Remember, whenever you set up the equation connecting the two of them, find the constant first. That will now be your standard equation, okay? So let's find the constant. So when x is 16, right? So therefore, when x is 16 equals to, we are looking for k. Our y is what? 4, right? So we'll put 4 here, square. I've told you why these values are given. They are given so that you can find the constant, okay? So that is the essence, that is their job. If you can find the constant, then you can find the one quantity given the other. So we now solve. 16 will be equals to k into 4 squared is 4 times 4, which is 16. Alright? So we now divide both sides by 16. So we have that 16 over 2 equals to k into 16 over 16. Sorry, we divide both sides by 16, so we can find k. Alright, 16 cancels 16. 16 here 1, 16 here 1. So therefore 1 is equals to k. So this implies that our k is 1. Okay? So our k is 1. So therefore we can write the equation. So therefore our x will be equals to 1, k is 1 times y squared. So we now have that 1 will be equals to 1 times y squared is y squared. So this is our true equation between x and y. Now we can solve. This is our first Example, our first question, our second question is the equation. Okay, sorry, our first question is the equation connecting them. That is I. And our second question is x when y is 3. So when y is 3, remember we have already found the equation between x and y, or relationship between x and y. So when y is 3, therefore our x will be what? Y is 3, so it will be 3 squared. That is square in y. So if y is 3, so we square it. Remember, x is y squared. So we now have that our x will now be 3 squared is what? 9. 3 times 3, which is 9. So when y is 3, x is 9. Then I y when x is 36. So when x is 36, therefore from the equation x is equals to y squared. So we'll put 36 here. We are looking for y, then we have y squared. Alright? So here to find the value of y, we take the square root of both sides. To find y, we remove the square root. And how do we remove the square root? By taking square root. Sorry. To find y, we remove the square. And to remove square, we need square root, alright? And remember, anything you do to one side, you do to both sides. So we square root both sides. So we have the square root of 36 equals to square root of y squared. So square cancels square root. Square root of 36 is 6. So 6 is equals to y. So therefore our y is 6. Now, before we go over to inverse, I want you to notice something. In this direct variation, notice that when a increases from 6 to 8, b increases from 3 to 4. Alright? Alright? Now, when b increases from 3 to 4, a increases from 8 to 12. Alright, so look at the three things here. Here, a is 6, b is 3. Here, a is 8, b is 4. Right? And here, a is 12, and b is 6. So observe this thing, that when b gets smaller, when b is smallest, a is smallest, alright? When b is medium, a is medium. When b is highest, a is highest. So that is for direct variation, alright? And the same thing here for direct variation. When y is 14, when y is 4, x is 16. When y is 3, it has stepped down by 1, it's 3. X is what? 9. X has stepped down by how many? By 7, right? X has stepped down by 7. So you see that shows that this is what? Direct variation. As one increases, the other increases. As one decreases, the other also decreases. So let's go to inverse variation. Inverse variation. Okay. If A varies inversely as B, then A changes in opposite manner as B. That is to say, thus A varies inversely as B if I, as A increases, B decreases. I as A decreases, B increases. Right? So that is for inverse variation. For inverse variation. So one thing about inverse variation is that if two quantities varies inversely to each other, it means that the changes on opposite manner. That is, as one in step high, as one step up, the other one steps down. All right. As one increases, the other one decreases. As one gets larger, the other one. As one gets larger, the other one gets smaller. Okay. As one becomes extremely large, the one becomes extremely small. So they are going like this in opposite direction. They are like opposite change. All right. So these are the two conditions. A varies inversely as B. If as A increases, B decreases, and as A decreases, B increases. So let's establish the relationship. So A varies inversely as B. A varies inversely as B is denoted by A varies, because they vary in opposite manner. So to demonstrate it has to be in opposite sense. So A is in opposite manner as B. And because the constant is being explained, is being introduced as a multiplication, so we look for the multiplicative inverse of B. So A varies inversely as B, that is in an inverse way with B. As we are using multiplication as our constant, so the inverse should be in multiplicative inverse. And the multiplicative inverse of anything is 1 over that thing, right? So you can see that A varies directly as what? Inverse of B. Or A varies inversely as B. Because if you assuming that 1 over B is a quantity now, then you see that A is in direct with this quantity, inverse of B. So A varying in that inverse of B is something as A varies directly as the inverse of B. So that is to say that as A increases, B decreases, because B is at the denominator now, okay? If B is at the numerator, that means they vary in the same manner, all right? But because B is at the denominator, they vary in opposite manner. Okay, so that is how to demonstrate inverse variation. This is inverse variation. All right, that is for inverse variation. And of course, I have introduced already direct variation. Why direct variation is like this? All right, so this is direct variation. Okay, now remember, whether inverse, direct, or whatever, so far it is variation, you need to introduce an equation. All right, to introduce the equality between them, you need to introduce what? Constant, because it is the constant that brought about the what? Equality. So this implies that A is equals to K over B, or K1 over B. All right, I introduce a constant, which is the same thing as A equals to K times 1 is K all over B. So this will be our equation for inverse variation, where K is constant. Where K is constant. Okay, so let's take an example. Okay, the question says m varies inversely as n, and m is 10 where n is 5. The relationship between m and n. M when n. Find relationship between m and n. M, that is find m when n is 12, and find n when m is 20. Okay, so let's begin. Now, as usual, we will solve with the same ideology we used to solve direct variation. The only difference is that we set up a different equation, a different variation notation, a different variation relationship, all right, by 1 over, right? 1 over. So that means that if we quantity varies inversely as the other, so it will be 1 over the other, all right? Okay, so here, but let's write our parameter first. They told us from the question that when m is 10, n is 5. So this is a variation between quantity m and quantity n, all right? So the question says that when m is 10, n is 5. So from the question we have that m varies inversely, right? This 1 over inverse varies inversely as n, according to the question. Then this implies that m is equals to k over n, all right? Where k is a constant, where k is constant. Okay, let's go. So from here, from this equation, we can find the value of k. So when m is 10, so here we put 10 as m. So we have 10 will be equals to, when m is 10, we have k, we are looking for k, our n is what? 5. So place 5 here. So if you solve these equations, like I said, if you don't understand the equation very well, go to my videos on equation, simple equation, and you will understand everything. So at this point, we can cross multiply or multiply both sides by 5, because 5 is dividing k. So opposite of division is multiplication. So multiply both sides by 5, or we can do cross multiplication. So anyone is okay. So let's do cross multiplication. 1 times k is k, 10 times 5 is 50. So the value of k is 50. So therefore, can have that our equation, our new equation becomes m equals to k is 50 or 50 over n, right? So let's solve the other part. They say we should find m when n is 12. When n is 12, so when n equals 12, so therefore our m will be, what is the equation? 50 over n, right? 50 over n. So our n is 12, right? So we can divide, right? 2 here, 25. 2 here, 6, right? So which is equals to how many 6 are inside 25? We have 4 6. There is 24 inside 25. 6 divided 24 is 4, remaining 1, all right? So it's 4 whole number 1 over 6. So therefore our m is 4 whole number 1 over 6. So you are converting 25 over 6 to improper fraction, okay? Improper fraction. So we'll go back to the next one. The other question say n when m is 20, right? So when, that is, this one is I, then I, when m is 20. So the question says here we have 20 equals to 50 over, from the equation, n. So at this point, you can use any pattern of your choice to solve the problem. If you want at this point, you do cross multiply, you still get the same result. Or if you want at this point, you can switch the fraction. You can do this over 1 and switch them. Then you multiply both sides by 50. Okay, so let's do cross multiplication. Cross multiplication, 1 times 50 is 50. 20 times n, 20n. Remember, we are looking for n, all right? And to make n the subject, n must come at the numerator, okay? So here, 20 is multiply n, so we can divide by 20, okay? So if we do that, I have 50 over 20 equals to 20n over 20. So 20 cancel 20, 10 here, 2, 10 here, 5. So we have 5 over 2, and 5 over 2 is 2.5, right? Plus n. So this implies that our n is 2.5. So that is the value of n. So notice in this inverse variation, when n is 5, m is 10. When n is 4 over 6, which is smaller than, when n is 12, which is bigger than n being 5, then m is 4 1 over 6, which is smaller than what? 10. So what you observe here is that as n increases, m decreases. And on the other hand, as m decreases, n decreases. So they always increase in one will not bring increase in the other. Rather, increase in one will bring a decrease in the other. That is for inverse variation. So I will establish more examples after the teachings, all right? So because of time management, so let's go into the next phase, which is joint variation. Joint variation. Like I said, we have only basically we have two types or kinds of variation. We have direct or inverse. Any other variation we introduced is an extension of an extension of direct and inverse variation. So joint, by the name joint, is a joined variation. So when joint variation occur when a particular quantity varies differently with different quantity. So definition. Joint variation is a type of variation whereby a quantity varies differently with different quantities. Varies differently with different quantities. So we continue with our definition. So this is continuation of our definition. Let A, B, and will I use C? Okay, not bad. Let A, B, and C be quantities. All right. Suppose that A varies directly as B and inversely as C. Then we can deduce as follows. Then we can deduce as follows. All right. So remember the question say we are talking about joint variation, and we say that a joint variation is a type of variation whereby a single quantity varies differently with different quantities. All right. So we have three quantities here. So from the question, we assume that A varies directly as B, that A is in direct variation with B, and the same A varies inversely as C, that is A is in inverse variation with C. So in such a situation, this kind of variation is called a joint variation, because the only way to express the three of them is by joining the three of them. So this is a compound statement which involves a particular quantity but having a diversified relationship with diversified quantity or with different quantity. So in this compound statement, if we break into two, the first part says A varies directly as B. So we can do this as follows. The first one, A varies, that is I, A varies as B. Then I says that, and that is this is a word we use to join statement, all right? So, and A varies inversely, and A varies inversely as C. So this inverse shows that A is an inverse variation with C, and this is how to write inverse variation, right? Now, to bring the three of them together, we need to invite that term, join. We need to join them. That is where the joint variation comes. So joint variation can only come when a particular quantity has a different or diversified variation with different quantity, okay? So from here, we can conclude, or in conclusion, that A varies directly as B. You know, the direct variation is a numerator, and inversely, the inverse is a denominator. Remember, this one is just to define this. This one is does not add to anything. It's just to give this one meaning, because if there is no one here, this C will be meaningless. All right. So to bring meaning to this, we need to use this one to express that inverse variation. So here we don't need that one anymore. C is here because this is something like saying B times 1 over C. All right. 1 times B is B, we have over C. So this over C you are seeing here is something as 1 over C. The 1 has multiplied with B to become B, all right? So this is the joint variation. This is the joint variation. But A is in direct variation with B and in inverse variation with C. That is, A increases or decreases with B. But here, as A increases, B decreases, C decreases, and as A decreases, C increases. But here, as A increases, B increases. As A decreases, B decreases. So these two are in direct variation, while these two are in what? Inverse variation. That is it. So since we have established the relationship connecting the three of them, here we can now, all right, in case if you do not see what I wrote here, let me bring it's like the light is stopping here. So let me bring my first sentence. I say first sentence, A varies directly as B. All right. So you can check the two. All right. You can check the two. So sometimes light is affecting here. So that's why I want to bring this thing down. So this is our I. A varies directly as B and inversely as C. So that is the linear relationship between A, B, and C. So from here, remember that whenever you have a variation notation, you always replace it with what? Equal sign. By we attach with what? A constant, because it is the constant that will bring about the equal sign. All right. So from here we can conclude that A is equals to K B over C. All right. So the K bring about the C. All right. Okay. Where K is what? Constant. K is constant. So let's take an example. A varies directly as B and inversely as C. A is 2 when B is 4 and C and C1. Find I, the relationship between A, B, and C, A when B is 10 and C equals 5. C when A is 12 and B is 9. The last but not the least, IV B when A is 20 and C is 0.5. Okay, solution. So the question says, okay, let's write the value when when A is 2, B is 4, and C is 1. Okay? Alright. So the question says that A varies as B, comma, and also at the same time A varies inversely as C, right? A varies directly as B and inversely as C. So this implies that A varies directly as B and inversely as C. Alright? By joint variation, I have joined them now. A varies directly as B and inversely as C. So what does it imply? It implies that A is equals to KB over C. Alright? Where K is constant. So the question says when A is 2. So we are going to find the value of K, right? And how do we find it? By substituting the respective value of A, B, and C. So when A is 2, so we'll put 2 there. When A is 2, I have 2 equals to K into B is what? 4. And C is what? 1. So this, so let me solve it here. This is 2 equals to 1 divided by K times 4 is K times 4. Anything divided by 1 is that. So we divide both sides by 4. Alright, so we have that 2 over 4 is equals to K over K into 4 over 4. So 4 cancel 4. 2 here 1, 2 here 2. So we have that 1 over 2 is equals to K. This implies that K is half. So the value of our K is half. Okay, so the I question says we should find we have gotten the relationship between, okay, now let's establish the relationship between A, B, C and A, B, and C. So from this equation, we have that A will be equals to, what is our K? Our K is 1 over 2 half is equals to K times BC. So K times B over C. So what is our B? Let me put it like this. What is our B? Our B there is, okay, so this is B over C. So if we'll multiply it, 1 times B is B over 2 times C. Remember, there is always multiplication between numerator and denominator, right? Okay, so 1 times B is B, 1 times C is 2C. Or you can call it half 2C, half BC. Alright, half BC. You can call it A equals to half BC. It's still the same thing. You can leave it like that, or you can leave it like this. So this is our equation. So this is the relationship between A, B, and C, or equation connecting A, B, and C. Alright? So now we can solve the question. So Our II question says we should find A when B is 10. So from the equation, we have that A is equals to, our B is 10. So we'll put 10 there times 2. Over 2 times C. Our C is what? Our C is 5. B is 10, C is 5. So B is 10, C will be 5. So we now have that our A will be equals to 10. 2 times 5 is 10. 10 over 10 is 1. Okay? Our II is, right? II says we find C when A is 12. So from the equation, A is 12, B is what? 9. So we have 9 here. All over 2 times C. We are looking for C. So at this point, we can make this over 1. We cross multiply. 1 times 9. Okay, let me say 12 times 2C. 12 times 2 is 24. Then C. 24, then C. That equals to 1 times 9 is 9. So we divide both sides by 24. So we have that 24C over 24 equals to 9 over 24. So this cancels. So therefore, have that C is 9 over 24. Okay? So that is the value of C. Then the last but not the least, we find B when A is 20. So from the equation, A is 20, IV 20 will be equals to A is 20. We are looking for B over 2 times C. Our C is what? 0.5. And 0.5 is the same thing as 1 over 2. Or you can say, if you move this once, it becomes 5 over 10, alright? And 5 here 1, 5 here 2. So 0.5 is 1 over 2, alright? So we can replace it with 1 over 2. So here, we have that 2 times half. 2 times half. This is over 1. 2 here 1, 2 here 1. 1 times 1, 1. Over 1 times 1, 1. 1 over 1 is 1. So 2 times half is 1. 2 times 0.5 is also 1. So even if I choose, I can put 0.5 here. The same thing, I'll have 1. So we now have that 20 will be equals to B over 2 times 0.5 is 1. B over 1 is B. So we have that 20 is equals to B. So therefore our B is 20. So we are done. Now let's go into, we'll have a lot of questions to solve after the lecture. So we go into partial variation. So our last phase is partial variation. So definition. So partial variation is a type of variation whereby a quantity varies partially with one or more quantities. One or more quantities. So the word partial means part of something. Alright? So when we say that partial variation is a type of variation whereby a quantity